Hello everyone, hopefully you're doing fine with Articosa. In this video I'm about to show you how to determine what type of a solution in the system of linear equation we have. We have a unique solution where we're having one solution. We have infinitely many solutions and we also have no solution. So we want to know for which values of k will this system of linear equation have one solution, have infinitely many solution, or no solution. And for that, we'll first have to write the system of linear equation in a matrix form. So this is in form ax plus b. What we'll do, we'll write it in this form because so that we can apply Gauss elimination method. We can reduce the matrix, so we'll be able to determine the values of k for which our solution will be no unique, infinitely many, or no solution. But we'll have to make sure the last row we're left with 0, 0, and we have something here so we can be able to determine if it supports. So the first step that I'm going to do, according to reduced echelon form, using row operation, I'm going to exchange row 1 with row 3 so that I can have the leading one. Secondly, below the leading one, I must have zeros. So applying the row operations, so row 2 will go to row 2 minus 2 row 1. So for this first entry on row 2, I have 0. Then the second entry on row 2, I have 2 minus 2k. And for this one, I have 1 minus 2k. And here, what do I have? 9 minus 2 times 5k, which is 9 minus 10k. And for row 3, my operation that I'm going to perform now, I'll say it will go to row 3 minus k row 1. So for the first entry, I have 0 on row 3. Then the second one on row 3, I'm going to say 1 minus k times k, so it's 1 minus k squared. Similarly here I have 3 minus k times k, I have 3 minus k squared. And I also apply this other side, I'm going to have 7 minus 5k squared. Now I have to make sure that this part becomes 0. And in order to do that, I can use row 2. The operation that I'm going to perform now, I must ensure that this term becomes 0. And for that, I'm going to say row 3 will go to row 3 minus 1 over 2 into 1 plus k row 2. So this will be 0, 0. So for this part, I have 3 minus k squared minus 1 over 2k plus 1 multiplied by 1 minus 2k. So I'll just have to simplify that. So to make it simpler, let's just simplify this term. Applying the FOIL method, so you have what? 1 times 1, you get 1. Then 1 times this, you have a minus 2k. Then k times this, you have plus k, so this becomes minus k. Then you have this times this is minus 2k squared. So it means here what I'm going to substitute this time, it's 1 over 2. No, I forgot this part, 3 minus k squared. So let's do it. 3 minus k squared minus 1 over 2 into 1 minus k minus 2k squared. And what do we get when we simplify this? And there I will result with k plus 5. Yeah, that's it for this part. Now I also have to do for this part the same operation, row 3, which if I check it's 7 minus 5k squared. Then I'll say minus 1 over 2, 1 plus k into 9 minus 10k. So I'll have to simplify that also and see what I get. So for 7 minus 5k squared minus half of 1 plus k into 9 minus 10k, simplifying this part, you can see it's 1 times 9 is 9. Then 1 times negative 10k plus k times 9, I get negative k. So, and also k times negative 10k squared. So I have this part, and to simplify this one, I can take 2 as my lowest common multiple. So here you will see what we have. I have 2 times this is 14. 2 times this is negative 10k squared. Then here you have minus 9 because of this, plus k plus 10k squared. If you can check, 10k squared cancels 10k squared, and 14 minus 9, you get 5. That's why the solution for this is k plus 5 divided by 2. So now this is the simplified form that I need. Then now I can determine what type of solution am I having depending on the value of k. So I can see very much well if k is negative 5, this part will be 0 and this part will be 0. And I will be having a form 0 equals to 0. So this is for infinitely many solutions. So this system of linear equation which I was given, it will have infinitely many solutions if k is the same as negative 5. But if k is not negative 5, it will have a solution. And also, there is no value of k that will make this system of solution to have no solution. Because for that to happen, we must have something like 0 equals to 2. And you know very much well that 0 cannot be equals to 2. So there's no value of k that can make this part to be 0 such that this part is not 0. That's the only situation where we have no solution, when this here we're having 0 but here we're having just a number. So there's no value of k that this given system of linear equation will have no solution. So that's it, what you are required to do. Thank you. Enjoy.